During the last session, we were discussing about functions, how the functions can be declared, how functions are defined, as well as how functions are called. We discussed all these three things. Actually, the function declaration is the same as the function prototype. Function prototype is also known as the function declaration, as in the case of the identifier declaration, the variable declarations. It is almost the similar as the function declaration. The function prototype is also known as function declaration. Then we said that the functions may need or may not need some parameters, some arguments as well as parameters, both are the same, are to be passed, or these parameters or arguments are to be passed into the function for the proper functioning of that particular codes, or for proper working of that particular function. And while passing these parameters, the parameters can be called or can be passed by one method, that is called by value, and there is another method that is known as call by reference. But call by reference comes only when we are using pointers, that we will study later. When we study about the pointers, then we will study about call by reference. Now we will discuss about call by value. Call by value is nothing but we are passing the value of that particular parameter or value of that particular variable directly into the function. So what happens is, in the calling function, in the the function which calls the particular function, if a variable is there, say a variable x is there, and the value of that particular variable x is changed inside the function. Even if it is changed inside the function, the value doesn't changes within the calling function, that is the function from where the function is called. It doesn't changes the value of that particular variable in that function. But in called by value, what actually does or what actually happens is that a copy of the original variable is created within the function which is being called. So that is the called by value. So in C, all the arguments are passed called by value, that is if the values are directly passed, then it is known as the called by value. This means that each argument is evaluated and its value is used in place of the corresponding formal parameter in the called function. The formal parameter is nothing but when we declare a particular function, we say that this particular parameter or this type of parameter is to be called, or this particular parameter is to be given for this particular function. That is when we declare, that is in the function prototype, we say that within brackets we say that this particular function, this particular type of variable, this particular data type of is there. That particular value, that type sort of value is to be passed into the function. That is what that particular referencing is known as the formal parameter. That is the parameter list or the list of parameters that is given within the function declaration or the function prototype. It is the formal parameter. Then there is another thing that is known as the actual parameter. The actual parameter is nothing but the actual variable or the actual value that we pass into the function while calling that particular function. That is, the formal parameter is the representation of the parameter list within the function declaration or within the function prototype. But the actual parameter is the actual value that is being passed into that particular function. So that is the difference. So in call by value, actually we create a copy of the value for that particular parameter, and then we work on that particular copy. Within the function we work only on that particular copy. We will see an example. And an example for called by value is given by computing the sum of an integer, the sum of the integer in the sense the sum of all the values from 1 to that particular value, say n. In this case, in this particular case, one second, okay. In this particular case, the function definition is, the function declaration is like this, or the function prototype is given like this: int compute sum, int n. So the compute sum is the function name, int is the data type that is being returned, or the return data type, and int n. So this is the formal parameter. As I said earlier, this one is the formal parameter. This is not the actual parameter. This is the formal parameter, int n. So we know that the n is not must here. It is an optional value. It is not required here actually. Then what the compute sum does is that it finds out the sum of the first n integers starting from 1. That is, if n is say 5. So in that case, it will find out the value of 1 plus 2 plus 3 plus 4 plus 5. So that is the operation of, or that is the function of this particular compute sum. Now we start our main function, int main void, then int n equal to 3, and we give n as 3. We are not inputting a particular value for this n. We are predefining the value. That is, it is not a user input. N is not a user input. It is input by the program itself. N is equal to 3, then sum. Printf %d / n. So we will go to the actual program right here. Rather than discussing it here, we will go to the actual program. Yeah, okay, here is the program. So here we give the hash include stdio.h, then the function prototype that we discussed. Then we define two variables. One is n, that is equal to 3, and the other one is sum. The value of n is initialized as 3 itself. Then the value of sum, that is to be found out. Then printf n before function call. That is, we are calling the function, and before calling the function, what will be the value of n. So that is what is being printed here. It will display printf, that is, it will print n before function call. So the value of n will be printed. Obviously 3 is there, so it is 3 will be printed. Now we call the function. Since the compute sum function, it returns a value of integer, we store the value that is being returned by the compute sum is stored into the variable sum. Sum is also declared as an integer type. So sum gets the value, the variable sum gets the value that is returned by the compute sum function. So compute sum, then it has a parameter int n. That is, the compute sum requires a parameter int, parameter of type int. So that is the parameter that is given in compute sum is n. N is an integer, n is equal to 3, and that particular value is given here. So this is the actual parameter. Int is the formal parameter, and here it is the actual parameter. That is the difference. Here it is. Here the function, the name n can be anything, no problem. And here the n can be different. It also is no problem. And that is why this is the formal parameter and this is the actual parameter. Actual parameter is the actual value that is being passed into the function while calling that particular function. And formal parameter is the parameter that is represented in the function declaration or the function prototype. So that is the difference between formal parameter and actual parameter. Then the function is called in this particular line, sum, and the value returned by compute sum is stored into sum. Then we again print n after function call. So after the function call, what is the value of n? That is being again printed here. We have obviously it will be 3 itself, because there is no change in n in anywhere in this function. Then finally we print the sum of the value. And in the function compute sum, what happens is int compute sum int n. So that is the function, the header of the function. Then within the body int sum equal to 0, and this sum as well as this sum, these can be different. These two sums are different actually. So that we will check how this these are related, whether these are related or not. So they are different. Then for n is greater than 0. So here we doesn't require n is equal to 3 or n. Because why? Because the function of the value of n, whatever be the value of n, it will be initialized here. The only thing is we are checking whether n is greater than 0 or not. N is greater than 0 or not. Then we are decreasing n by 1. So n is decreased by 1. Then we add the value of n into sum. The value of n is added to sum. So when it is 3, when indeed n is 3, that is when the function is called first, that is when the control is transferred to this particular function, n is 3. So what happens is n is greater than 0. Since n is 3, n is greater than 0, sum is 0, sum is initialized as 0. So 0 plus or equal to 1, so that means sum becomes 3, n is 3. Then in the next for loop, n is reduced by 1. Now n is reduced by 1, so it is n is 2. So 2 is greater than 0. So sum is 3, 3 plus or plus equal to 2, so it becomes 5. N is again reduced by 1, so n is becomes 1. 1 is greater than 0. Sum plus or equal to n. Sum is 5. 5 plus equal to 1, so it becomes 6. Then again n is reduced by 1, so now n becomes 0. Now n is 0. So we are checking whether n is greater than 0 or not. N is not greater than 0. N is equal to 0. So the for loop ends. So now sum is 6. Now printf n inside the function. So we are printing the value of n inside the function here. So to check whether the value of n is varying. So within this function n, within this function compute sum, the value of n became 0 right now, and then we return the value sum. But after the function call, that is within the main, the value of n doesn't changes. It is the same as 3 itself. Now let us run it. See, n before function call is 3, n inside function is 0, n after function call is 3, and the sum is 6. So that is how the function call happens. That is call by value type happens. That is the value of the variable inside the main function doesn't changes. And as I said, the name of these functions, these variables is not important. Instead of n, here I am giving x, and here also I have to give x into x. So now what happens is, here since it is x, this n is also has to be x. So these values are to be x. Why? Because we have changed the function here. The name of the variable here. That is why we have to change it. So now let us run it. So sorry, here another n was there, I haven't changed it. So now we are compiling. So no errors. We are running it, the same thing, n before function call, n inside 0, n after function call, sum, etc. So that means this variable as well as the name of this variable need not be the same. This is the formal parameter and this is the actual parameter. So it can take any name, no problem. And another case is, here is a sum as well as here is a sum. It need not be the same as here. Here we can give it as s itself, no problem. Here also I am taking it as s. So obviously the return statement also has to be s. Any variable name you can use. S I am just taking as s. So the same thing is happening. So the function name, the variable names within the main need not be the same as the variable names within the function. That is it. And when a parameter is passed by value or called by value, the value of that parameter within the calling function doesn't changes. The function that is being called will change that particular value within that particular function only. It doesn't changes within the calling function. So that is about the call by value condition. Now let's see another program in which we use two different functions. In this case, what we does is we calculate NCR with the two functions. You know what is NCR? NCR is n factorial divided by r factorial into n minus r factorial. So let me try to write it down. So NCR, it is commonly written like this: NCR equal to n factorial divided by r factorial into n minus r factorial. So this is what is NCR. So in order to evaluate this NCR, we use two functions. One is to find out this particular value, and the other one is to find out the factorial values, the factorial of n factorial, r factorial and n minus r factorial. So here we have to find out three different factorial values. So in order to find out the factorial values, we use a function, and another function is used in order to calculate the NCR also. So this is the program. In this one we start with hash include stdio.h, hash include stdio.h, then hash include conio.h, long myfact index. So this is the function declaration or the function prototype. So this is to find out the factorial. Myfact is to find out the factorial. So it will return a data type of long because it is a factorial. You know that 6 factorial is 720. So 10 factorial is some very large value. So that is why we use a long return type here. So then myfact integer x is the value for which the function the factorial is to be found out. That can be int only. No need to give x, that you know. Then long NCR into n into r, the function declaration. So long NCR, this is the second function. This is in order to find out the value of NCR. NCR, as we have seen, that is n factorial divided by r factorial into n minus r factorial. So that we have to find out using this long NCR. So here we start with the void main. Void main is started. So int rr and nn. So we give two values, rr as well as nn. Instead of rr we can take it as r itself, and because that will be easy to read. Okay. So int r and n. Then long fncr, fn, fr, fnr. So these three values. This is the values r and n for which we have to find out NCR. And then long fncr is the factorial of NCR, the value of NCR. Then fn is the factorial of n, fr is the factorial of r, fnr is the factorial of n and r, that is n minus r factorial. So printf, give the values of n, give the value of n, and it is cant %d ampersand n. Printf, give the value of r, the value of r is canned here. So n and r are obtained using these lines. Then we go to the function. The function is fncr equal to ncr nr. NCR is the function using which we calculate the value of NCR, that is n factorial divided by r factorial into n minus r factorial. That value is calculated using this NCR function. And the return type the value that is being returned by this function, it is being stored into fncr. The variable fncr stores the value that is being returned by the function ncr. So then we print f the value of ncr is fncr. So that is then first we define the function ncr. So the return type is long ncr int n int r. So we need two functions, I mean two variables in order to calculate the ncr. So the first value that is required is n and the second value that is required is r. So then within this thing we need long fn, fr and fnr. Long fn, fr and fnr. Fn is my fact n. So it is a function call. My fact is a function. So we are calling that particular function in order to find out the factorial of n. The factorial of n. Say factorial n is 6. In that case, if we want to find out the function factorial of n, we know that the factorial of 6 is 6 into 5 into 4 into 3 into 2 into 1. So in order to find out that particular value, we use this particular function, that is my fact. Then fr. Fr is assigned with the value my fact r. The factorial of r is given to fr. Then the factorial of n minus r, my fact n minus r, that is given to fnr. Then what we have to return is, we return fn divided by fr into fnr. That is how we have defined the ncr. N factorial, this fn is n factorial, fr is r factorial, fnr is n minus r factorial. So that value is being returned then. So that is how this ncr function works. Now the function my fact is called from this ncr function, and the my fact is, within the my fact we have only one parameter, that is int x. X is the value for which we have to find out the factorial, and in that case we have a counter I, int I, then long p equal to 1. Long p is initialized as 1. So if x is greater than 1, for I equal to 2, I less than or equal to x, I plus plus, p star equal to I. So suppose x is equal to 5, x is given as 5. So we want to find out the factorial of 5. So when x is greater than 1, so x is greater than 1, x is 5, so x is greater than 1. So in that case, if we want to find out the factorial, for I equal to 2, I is initialized as 2, then I is less than or equal to x, I obviously 2 is less than or equal to 5, so I plus, then p star equal to I is 2, p is 1, so p star equal to I is p into 2, that is 1 into 2, so p becomes 2. Then I is increased, I became 3, then again I is 3, so it is less than 5, p into I, p is 2 here, 2 into 3, that is 6, p is now 6, I is increased, I became 4, likewise it goes on till I becomes 5. When I becomes 5, I is less than or equal to x, so x is also 5, so I is equal to 5, so I is again, once again it is being utilized or being operated, p star equal to I, so p is multiplied by 5 again, so that is p is multiplied by 1, 2, 3, 4 and 5. P is initially 1, that is why we are multiplying it with 1, or we consider it to be multiplied by 1. So all these values, so we get the value of p as the factorial of 5 in this case, if x is 5, then we return p, the value of p is returned. So when we call fn my fact as n, when n is 6, the factorial of 6 is calculated and it is sent back. Suppose if x is 1, what happens? P is 1, p equal to 1, and x is not greater than 1, x is equal to 1. So this lines of code, it won't happen or it won't execute. Instead, return p will happen. The p will be returned, that is 1 will be returned. You know that 1 factorial is equal to 1. The factorial of 1 is 1 itself. So 1 will be returned. So this is how this particular function is being executed. Now let's try it and let's run it. So I am giving the value of n as say 5, then the value of r, say it is 3. So the value of NCR is 10. That is 5 factorial n factorial. N factorial is 5 factorial divided by r factorial. R factorial is 3 factorial, and then n minus r factorial. N is 5 and r is 3. So 5 minus 3, that is 2 factorial. So 5 factorial divided by 3 factorial into 2 factorial. 5 factorial divided by 3 factorial is 4 into 5 divided by 2 factorial. 2 factorial is 2 itself. So it is 10. So the value of NCR becomes 10. In this case, that is when n is 5 and r is 3. So this is how we find out the value of factorial or NCR using two different functions. We have two different functions here. Now the next thing is recursion. Recursion is something like calling a function in itself. That is a function which is being called by itself. That is known as a recursive function. The functions can call themselves, like myFact function. The myFact function can call itself. Such a function is called recursive. That type of function, that is the function which can call itself, is known as recursive function. But some conditions are to be satisfied. If we call the myFact function as we defined in the previous case, then it will throw an error. So recursive function has to satisfy few conditions. Recursion is the process of defining something in terms of itself, and it is also called a circular definition. That is, the recursive functions are also known as circular definition, or the way in which the recursive functions are created, it is also known as circular definition. So in order to solve a problem recursively, two conditions must be satisfied. That is, the recursive functions must satisfy two different conditions. That is, the problem must satisfy two conditions. The first one is the problem must be written in a recursive form. Recursive form in the sense that a function is calling itself. That way we have to write the function write the problem in such a way that the function calls itself. Then the problem statement must include a stopping condition. The problem statement must include a stopping condition also. That is, there should be some way of stopping the conditions, otherwise it will go infinitely. If in the case of myFact function that we seen in the previous case, if we call like a recursive function, if we use it like a recursive function, then obviously it will go on indefinitely, because infinite times it will continue to run. That is, it won't stop because it doesn't have a stopping condition associated with it. So now let's see some examples of recursive functions or recursive methods, or the examples of recursion. So the factorial of a number, that can be found out using recursion. In the previous case, actually what we did is we doesn't use the recursive condition or recursion, we haven't used. We calculated it directly. We were using it directly, like this one itself we calculated it. That is n factorial equal to 1 into 2 into 3 into multiplied by up to n minus 1 into n. That way we calculated. So this can be written in another way, like n factorial equal to n into n minus 1 factorial. So n into n minus 1 factorial. So if this is n factorial, if we remove this particular n, if we strike off this particular n, whatever remaining is n minus 1 factorial. So that way, and if we multiply n minus 1 factorial with n, it becomes n factorial. That is how it happens. So n factorial equal to n into n minus 1 factorial. So like this, and n minus 1 factorial can be written as n minus 1 factor n minus 1 into n minus 2 factorial, like that it goes on. So continuing like this, we reach somewhere like 2 factorial equal to 2 into 1 factorial, 2 into 1 factorial, and 1 factorial is always, that is 1 factorial is 1 itself. So this is the stopping condition, that is for a recursive function to find out a factorial of a value, the stopping condition is 1 factorial equal to 1. And this is one example of recursion. Then another example is finding out the Fibonacci numbers. Fibonacci numbers or Fibonacci numbers, it is also known as Fibonacci numbers, in which the first two numbers are 0 and 1. So the first two numbers in a Fibonacci Fibonacci series is 0 and 1. Then the third number is the sum of the previous two numbers. Fourth number is the sum of the previous two numbers. Likewise it goes on. So it will be something like, if you find out the Fibonacci series, it will be 0, the first value is 0, the second value is 1, then the third value is the sum of these two, 0 and 1. So it is again 1. Then the next value is sum of these two values, 1 and 1. So it is 2. Then the next is 2 plus 1, 3. The next is 3 plus 2, 5. Then next is 5 plus 3, 8. Likewise it goes on. That is any number is the sum of the previous two numbers. So in order to find out a particular number, in a Fibonacci series, we can find out like this: Fibonacci of n plus 1. If it is the nth number, that is the first number, if n is 0, if n is 1, so this is 1. So 1 plus 1, that is 2, that is the second number. So the second number can be, because in the case of Fibonacci series, the first number as well as second number is fixed, 0 and 1 is fixed. Then from the third number onwards, we can find out Fibonacci of the previous two numbers, adding the previous two numbers. So that is Fibonacci of n plus 1 is equal to Fibonacci of n plus Fibonacci of n minus 1. So this is how this can be, the Fibonacci number series is can be found out using recursion. Now let's see an example program. So this is finding out the factorial using a recursive function. In this case, again we start with hash include stdio.h and hash include conio.h. Then the function declaration, long factor index. So whether it is a recursive function or not, the function declaration or the function prototype is the same. It is the same. Long factor int x. Then void main. We start with the void main. Then int n. Print give a number. Give the number for which the factorial is to be found out. I am limiting it to 12. The value of the factorial for which the factorial is to be found out, the number for which the factorial is to be found out, that is limited to 12, because otherwise if I go above 12, it will give some answer, but it is not accurate answer. So then scanf %d ampersand n, then print n factorial equal to %ld, the factor n. So here we are calling the function. We are calling the function within the printf itself. Instead of saving the value, the factorial of that particular value, into another variable, we are calling the function within a printf code itself, within a printf function itself. printf is a type of function, it is another function. So within that particular function we are calling the factor n. So factor is the function that is used to find out the factorial using recursion. So now the function definition of the factor. So long factor index, this is the function header. Then if x is less than or equal to 1, if x is less than or equal to 1, we return 1. That is, when x becomes 1, we return 1. Else, otherwise, if x is greater than 1, in that case, return x into factor x minus 1. So this factor x minus 1 calls this particular function again, once again. That is, when we call this factor x minus 1, this factor, the function factor is again called with a value of x as x minus 1. Suppose we are trying to find out the factorial of say 4. We want to find out the value of factorial 4 factorial. So x is 4. Now x is 4. Since x is not greater than 1, I mean not less than 1 or not equal to 1, we have to return the value 4 into factor of x minus 1, that is factor of 3. So when we call the factor of 3, now it is 4 into, now factor of 3 is to be returned. So it again calls this particular function. Then in that case, now x is 3, x is still not less than or equal to 1, so else it goes to this value. So in that case, 3 into factor of 2, 3 minus 1, so factor of 2, again calling here, x is not less than or equal to 1, so else condition, return 2 into factor of 1. Now it comes here, x is 1, so x is equal to 1, so we are returning 1. So the control comes back here, factor of 1 is 1, now it was 2 into factor of 1, so it is 2 is returned. Now the second level happens, 2 is returned, then 3 into factor of 2 was there, factor of 2 is 2, so 3 into factor of 2, that is 3 into 2, so it is returning 6, so 6 is being returned to the highest level. So in the highest level it was 4 into factor of 3, factor of 3 we got it as 6, so 4 into factor 6, it is 24. Then finally it is being returned, that is 24 is being returned. So 4 factorial is 24, that is we know 4 factorial is 24. So that particular value comes here, that is 24 comes here, and that particular value is displayed here also. So let us try it. So give the number which is something like less than n. So I am giving 6. So the factorial, n factorial is 720. So the value of factorial is 720. So let's try, let's do something else here. Let's how many times this particular function is being called, the function factor is being called. Let us print f, the value of percentage d, the value of x. Let's print the value of x. So with that one, okay. So let's see how many times the value of x will be printed. So here I am again giving the value as 6. See, initially it was 6, then it became 5, then 4, then 3, then 2, then 1. As we discussed, it takes all the values from 6 to 1, and when the value of x becomes 1, it returns the value as 1. Otherwise it goes to x into factorial of x minus 1. So this is how a factorial is found out. The factorial of any number is found out using recursion.